I put it into my calculator and I put it in like 10 times because I was like, I'm doing something.
Yeah,
wrong.
it was an SSA, and when you did sign inverse, and as long as it was set up correctly, if you did an error, it's impossible. So yeah.
I saw, yeah, I saw it.
Did it just click? Like, it didn't click on Wednesday. Today.
52
Okay.
was a little bit longer because it was a word problem. You had to kind of think about what the situation was. You were still doing ultimately an AAS, which is a nice one.
Yeah, I tried that.
It's extra credit.
Oh,
I got it. Wasn't that bad, was it?
I was hard.
that was the extra credit.
Well, you have to kind of set it up. So some of you might have gotten a little stuck because you might not have realized when they told you the 80 degrees and the 65 degrees, they weren't giving you the angles of the triangle. Check out the picture. They were giving you the bearing too. Is this the different pliers? Is that one?
Misty, I don't think we had number 50.
It was extra credit.
No, 62 was extra credit.
No, 62 was mandatory.
No, it was a 7. It was like
Wait, no, okay. Oh, 52 was extra
We never
credit.
did any 7.
No, I see. Yes,
62
no, I see.
was the weird one with the chart in the book that you were trying to compare. 56 was
Bless
the word problem that you had to do. And so I'm guessing that a lot of you guys would like this to be a bit zoomed in. So then, letter A. Now, they did it kind of to scale, which is why it's awkwardly long, because it's really short. And this is not even long. This is the hypotenuse. So 58.36 is the hypotenuse. So if you guys hadn't realized that, you might have gotten messed up as to what trig to use. We're using trig because it's a right triangle. So we can say, hey, we have opposite, we have hypotenuse, let's go. It was technically a right triangle. The tower is leaning, but if you're looking straight up to make that triangle of how far you are from the tower, that can be a right angle. It's a leaning tower of Pisa one, right?
Yes.
Oh. So you have your tower coming here and going out. You have straight up and then over as far as how far away you are. So you can make that right triangle. You have opposite over hypotenuse. You can use a sine function to solve. That's nice. Once you have that angle, now you can go ahead and think about this other situation where you have, once again, your Leaning Tower of Pisa, but now you're talking about being any distance away, not just the 5.45. So you can set up your little sine of beta over whoever that distance is equals sine of theta over that Leaning Tower of Pisa height, or length, I guess you could say, either way. Height's kind of more straight up. This guy's leaning. Then we can go ahead and just get beta by itself. That's what they were saying when they said get beta as a function of, because beta needed to be alone. That little angle up here at the top needed to be alone. And once you got him alone, just rearranging law of sines, sine inverse both sides, then you're able to go ahead and plug in stuff that you know for this specific example. Like they give you 95.26 as your angle up there at the top that you can plug in. Yeah, C was plugging in.
I just put a big question. The whole thing was like, oh yeah, this is the
Oh. You weren't plugging in beta. You were plugging in 4 beta. They told you what the angle was of lean to the Leaning Tower of Pisa. So that angle of lean was 95.26. You're like, okay, there's 180 degrees left over for those two guys. Sorry, 180 minus. There's 84.64 left over for the other two guys. So then this guy doesn't have to stay another letter like he was. He can actually be written saying, well, I don't know what he is, but he shares these many degrees with this dude to make a triangle. So you can actually write a little expression for who he is and plug that in. And all of a sudden, I no longer have 3 variables. I only have 2 variables, which is a much more normal function for me. So they say, well, even better than getting him alone is thinking of their relationship and how they share these 84.64 leftover degrees. And then I can get everything on one side. And even better than having this is having d as a function of just theta, because I can put it into my calculator as a y equals, and I can say, what if theta is 10? What if I'm at an angle of 10 degrees, or 20 degrees, or 30 degrees, or 40 degrees, or 50 degrees? what will my distance be?
Yeah, let's just take BC.
Oh, did it just disappear?
Yeah.
It must have been like in some reprinting of the book. They meant to have a D and then they lost it.
I thought there is a D.
Was it on the
Did
next
you
page?
do D? Well, I wrote down the instructions for D. I didn't do D.
It must have been on the next page.
Can
Which
I
is awkward. Was it awkward?
No, because it was at the top of the page.
Yeah.
It gave you a table and it said complete the table.
Oh.
What is it? I don't know.
That whole problem was like,
And then number 62. You know it's 3 and 4, so you can say, hey, the other side is 5. Got it. And then once it's a 3, 4, 5 triangle, you can kind of play with the different relationships as to when it's 1, when it's 2, or when it's no solutions.
Oh, there is D.
Oh, there you go.
wait, what was it? Where was it?
It's like at the bottom. It just looks weird.
Um,
It's a chart. They give you a chart to fill out. Yeah.
So we have 4, we have 3, we have
I
5.
just gave up on the problem that much.
I think I just got excited.
So if we have 4, 3, the point 4, 3, right? We would go over 4, we go up 3, which means that diagonal is 5. And then they're saying, okay, what would this side need to be? Well, 3 is straight down. So if it equals 3, there's only one triangle. If it equals 3, it has to go straight down to connect, to make that little triangle with those pieces. So if A equals 3, this must have been just one case, and then this one's 2 cases, and this one's no cases for SSA. If it's 3, it's straight down, only one triangle. If it's less than 3, it's too short. It'll dangle with this angle, and it'll never hit. So if it's less than 3, it's too short. It can't connect. It'll just kind of like hang there and be like, oh, it's not a triangle. So that's a less than 3. And then you had to figure out, well, what is the other marker? And the other marker is this 5. Because if it was like 6, it would be like that weird 22 one yesterday, which you might not remember, but the one with the way longer side. If it's like 6, or if it's anything bigger or equal to 5, it won't be able to swing back because it'll either hit at the exact same place, which isn't a triangle, or it'll hit way out here somewhere, which totally overruns the guy you have to keep. So anything greater than or equal to 5, nope, that doesn't work. So therefore, okay, anybody between 3 and 5 is going to be able to hit out and in and have 2 different triangles. But that was kind of using like the picture in the book, that illustration diagram chart I showed you yesterday, and kind of using just how you can put together these different pieces. This morning I heard the phone though. Yeah, Jaden.
Can you go through 35?
35. Yeah. Oh yeah. What was 35?
So they gave you an angle and a side, like angle A equals 36 degrees. A equals
And you were trying to find the. Oh yeah, that's actually even harder than 62.
Yeah.
Okay.
Oh,
So 1 and 2 and none. Cool. Let's go ahead and put that in our notes so you guys don't mind. Okay. So that's number 35. And then what were the 2 pieces of information? Angle A.
So angle A equals 36 degrees, and then the little a is 5.
I think this one's awkward too, if I remember, because it's giving you that opposite side. It's not giving you like the 62 gave you the adjacent side. So I know. Here, I'm gonna do this one. Ready? Protractor, because we can do that. Where'd he go? Oh. Okay, I'm gonna spit out a 36-degree angle. Got him. Okay. So now I have my perfect 36-degree angle. And then let's go ahead and spit out, let's do 5 centimeters.
Metric system.
Yeah, because 5 inches, he's going to be kind of long. I don't know, I didn't want to have to deal with him. Okay. And then he has to go somewhere across from A. We'll just pretend that's it.
The other way.
Okay, but I'm going to go ahead and actually extend this dude. So let me extend this dude just a bit. Because we don't know exactly how long he goes, so I'll make him really long, or how far he goes. They didn't tell me anything about those two sides. Okay. So if I label this stuff, and it's going to get a little messy as far as labeling, so I'll just make this guy blue, so that's my 5 over there. And then my 36, bless you. Oh my goodness. Okay, we're supposed to go in what order? What comes first? How many solutions? One solution. Okay. The way we just did number 62, isn't one way to have one solution if this 5 goes straight down? This 5 goes straight down. It'd be right about here. Yeah? This would be a right angle. Boop, boop. How long would this side be if it was this case where we have a right angle? This is 5. This is 36. How could we solve for our little unknown side over here? Who's this guy, B?
You gotta get the other angle first.
This is H right now.
Oh, because you just add
That's
36
90.
and 90.
Yeah, and then you get the other angle.
We could do that, or could you just do sine? Because it's opposite and hypotenuse.
Okay.
So we could go ahead and say, well, okay, one way to have one solution is if you have a right triangle. If you have a right triangle, B would need to equal 5 sine of 36. Can someone throw that in the calculator real quick? 5 sine of 36. That's going to be a right triangle. 2.984.
2.94.
Okay. So 2.94, that's going to make a right triangle if B is 2.94. Which means my 5 is a little off, which is kind of awkward. Why is my 5 so off?
Why is it off?
I measured in centimeters.
No, it should.
Maybe. But degrees are kind of dimensionless. Are you in degree mode, not radian mode? Just double checking. You are, right? Oh, that looks so weird. Maybe I should be in inches. Okay. What else? What would make no solution? What would make no solution? What if I was to bring this up at all? Which means B is a little bit longer, right? If B was a little bit longer, what's the problem with my 5 now? Oh, just swing him, and it'll, doesn't it go up if it swings? Either way. Is it going to get any closer to the line by swinging?
You get no solution.
Yeah. So if I go above 2.94, it's going to not, because remember, the shortest distance between this side and this side is a straight line, straight down, 90 degrees. So right here at or if B is 2.94, that's the longest B can be. If B is any longer, he's not going to be long enough to hit. So right away, I'm like, okay, which one's no solution? Is that the bottom one? Okay. So no solution is if B is bigger than that. If B is bigger than that, that whole little 5 is too short, no matter what. Now, if B is shorter than 2.94. If B is shorter than 2.94. Hold on. What if I bring this 5 down just a little bit? Can he make a triangle, yes or no?
Yeah.
Yes, because I can just swing him out, right? Yeah. Oh, because I'm doing it if 5 is B and not if 5 is A. That's why it's so weird. Yeah. So my picture's not that. It was just another picture. I should have written it. Because opposite over hypotenuse. So sine of 36 is equal to 5 over B. So then B times sine of 36. I'm trying to do it too fast. That makes more sense in my picture. Okay. So one solution would be, so we need to change this one too. B is equal to 8.50. So then B is bigger than 8.51. Nice thing is our logic is still good. We just had the wrong side. So then 8.5 is longer than 5. Okay, that makes sense. Wait a minute. We went just a little bit shorter. We just went a little bit shorter and he swung out. But hold on. Remember the ambiguous case. It's not just swinging out, it's also swinging in, right? So what happens if I swing him the direct other way?
Wait, so what?
Because the ambiguous case. Remember, you don't just have to swing out, you can also swing in sometimes. Does this still work? Yes. But is it going to always still work? No, because if I kept on coming in, when will I not be able to, because I can still swing out. I wish it swung the way I wanted it to, but that's okay. I can still swing out, but can I swing in? Uh-oh. You guys see it? What's the problem?
Too long.
It's too long. Now I'm going. There we go. Is that it? To connect, I have to go past. And as soon as I... Oh, sorry, it's backwards. There we go. As soon as I go past, who is no longer a part of the triangle? And so I've actually just... Yeah, the 36 is no longer in my triangle. It's this weird, awkward outside guy. Okay, so at what point will my 5 be too long? Do you guys know exactly?
When it's the answer, it said 5 is less than.
Well, but check it. Check it. Isn't my 5 going to be too long when it would swing in and actually hit that side? Do you see it?
Yeah.
5 is now too long because check it. If I swing it, it is that other side. Wait, if it is that other side, then B is 5, right? 5 and 5. So it's going to be too long as soon as I hit that other side of the triangle, and anything past that, oh, it's going to keep having to swing. So therefore, it's like, oh, okay, so if B is greater than or equal to 5. If this is 5, like that is 5, well, I can't swing because I'm going to hit right there. Or if B is 6 or 7 or 8, it's going to be too long, and if it tries to swing, it'll... Wait, if B is less than or equal to 5, so B is this side. I'm thinking A, because that's how most problems are. If this little side is 5, or if it's smaller than 5, then this guy would try to swing and it wouldn't work. There we go. So then what's left is 2 solutions, and 2 solutions say, well, as long as that B is something higher than 5, so it won't swing in and hit it. As long as it's something higher than 5, but it's not too long, it's not 8.51. As long as it's higher than 5 and not too long, 8.51. And I'm good.
It's karma.
Karma, what does that do with the triangle?
Because I got up to get a tissue and I forgot why I got up. I set back down.
I'm not sure it's karma, but it is something. Okay. Tricky, weird, beyond anything you'll see on a test, but definitely making you grapple with what's really going on when you have 2 different cases, or no cases, like you guys freaked out when sign inverse got you undefined, or 1 case. All right, need everybody in every single group to stand up, turn around once, and give someone a high five, because I have people who are sleeping and they need to wake up before we go do notes. Stand up, turn around once, give a high five, or 2 or 3 or 10. All you party poopers that never do anything I say. I still love you. Alright guys, we have new formulas, but we need to figure out how to use the new formulas and why on earth I put big old parentheses around half of them. Because if you're like, we don't have to memorize these, that'd be nice, except you might have to use them, so why are there parentheses around them? Hey guys, that whole listening thing doesn't work well when you're talking. Here we go.
Emma didn't give me a mic.
I'm so sorry. Technically only we're supposed to give 1, but you could have given more, but if she decided not to, maybe she's ready.
No, it's no.
Oh, if she meant it as a personal affront,
Emma doesn't like me.
praise Jesus that his view of you does not ever change. Double check yourself as to whether or not there's something you could be doing better in order to not offend. And then chalk the rest up to OY. Here we go. S.
What does that have to do with math?
SS.
Life lesson.
Oh.
Side. How to behave in a classroom and how to behave in life.
So you just
There are
don't
things to learn. How to behave in a job.
How
How
to
to behave
behave
with friends. Like that whole listening takes actually being quiet. That could be helpful in friendships, in parent-child relationships, in sibling relationships, in marriage.
That's good because I'm never gonna use it.
Did Kayla call you yesterday wondering where I was?
Yes.
Yeah, my whole family.
Where were you?
I was just with Dad.
I
I
mentioned,
called
I was
my
like, you
mom.
might just be working out. She's like, yeah, I know, we'll go back and check.
I called
They were
my
just
mom.
worried. Because they care.
And then, of course, we were scared. And then, but my dad never gets home that early. So then when I got home, he's like, your kid
Because he
is not
called, she
texting me. Yeah, and I don't have my phone on me while I
Right.
so
Do you ever
I
just turn on the volume though when you're in the weight room?
just keep my Bible.
That could be something.
Would you be able to hear it though?
No, I wouldn't.
Oh, because
Probably
the
not.
music's probably quiet.
You can't even walk.
They're like 8 surgery. Maybe you can walk.
It's alright, because they care.
When that girl number 7 on your team knocked,
Uh-huh.
knocked the Marinette
You guys trying to plug in?
on the floor.
No.
I'm trying to write down.
Oh.
Mariah, is that
Oh,
like
Mariah.
knocked the okay, and I like yelled, and their whole bench like turned around.
Their parents are so annoying. Marinette's parents are the worst.
Alright guys, I love you, but it's not helpful. Okay, so a squared is equal to b squared plus c squared minus 2bc cosine of a. Is this a formula that could be used for this problem? Why did I choose this one? There were 6 different ones, but I put parentheses around 3, so there are 3 original ones. Why did I choose this one?
Because we're looking for A.
And this is the only one, can you guys see it? This is the only one that has an angle A out of those first 3. Now, what's the struggle with where the A is?
It's
Stuck.
Yeah.
Look at him, like he's, whoo, look at all this stuff that has to happen before I get to him. Now, here's the crazy thing. I could plug in numbers for all of these guys. And in last night's homework, didn't it have you sometimes like solving for a variable in like the law of sines formula? Like get him alone, or get him alone, or get him alone, right? How would you get cosine alone? Well, I'd subtract this dude. PEMDAS. I'd subtract that dude. I would divide this dude. Oh, and then I would have this guy alone. Now, I had to do a lot of reverse PEMDAS.
that's
Subtract him,
That's all.
divide
That's
all
all.
of, because it's times. And then it's like, ew, I have a negative? Why not factor out a negative and factor out a negative and instead get, let's see, something like b squared plus c squared minus a squared, all the signs flip, all over 2bc. What does this?
alternate form.
Could you memorize that and just go straight there?
See.
Yes. Do you have to? Didn't I just get there by just moving?
Oh no.
So it's up to you. The alternate form is really nice if you're like, I just want to go straight to plug it in. Okay, cool. Use the alternate form and say, there's A. That's fine. Or if you only want to memorize 3 formulas, have this guy down and just be really good at moving. Either way, if we go to plug in, won't we, let's see, have A, have C, have B. We got this. Because we want A, which means we start with, a way of memorizing, we start with A, and everybody else is minus. So minus the other dude, all over 2 times the other dudes. Now the problem is A alone? No. That's easy, which is why I wrote down,
Cosine inverse.
just take cosine inverse. And some of you are having like a little bit of PTSD from the sine inverse being like, ah, there are 2. No, cosine inverse, like a little bit of like, anxiety. I said a little bit, I'm not minimizing the actual condition. Just a little bit like, but it's no worries, because the nice thing with cosine inverse is cosine inverse has the same sign either up or down, and this can be in a triangle, and this cannot. So we don't even have to worry about the supplement because the supplement is something totally different. So we get to totally ignore the whole SSA ambiguous case. If we do cosine inverse, it is not ambiguous. The answer is what it is. All you gotta do is just plug it in, plug it in, plug it in. But use that big old fraction, guys, because it'll just help you organize everything a lot better. And we have 64 minus, I don't know, 19 squared. I don't know, 14 squared. Right. And 2 times 19 times 14. I put it in a big old fraction once, and I get straight to my final answer because I put it in just once. Just once. One little, and it goes straight to my answer, which is nice. So I get 157.9253.
Wait.
I put it in once because I used that nifty fractiony thing with a cosine inverse in degree.
Oh, I got it.
Sorry, I always do 3 decimal places because of my calculus training.
But I get 157.81.
Something went wrong, buddy.
I get 0.81, not 0.925.
Anybody else get 0.925? 64 is 8 squared, right? Minus 19 squared.
No, I got 157.81.
Oh no, something went wrong in your calculator. Did you type in something wrong? Double check. 8, 19, 14?
Yeah, I'm off by 1 decimal point.
Wow. Now guys, this is actually one of the harder types of problems if you're given an SSF. Ooh. Here, do cosine inverse. And then do a big old fraction. Just type it all in. So I bet you rounded something and so it threw you
What
off.
was that?
Oh, this is weird. You have 14 squared in the exponent.
Oh.
See? Maybe I'll be like up there.
No.
I'll just make flowers.
Why did you get
There it is.
There you go.
Minus.
Minus. Because Claire, you would have said put the whole numerator in parentheses to keep it by addition and subtraction. Okay. SSA is kind of the hardest one because we have to do cosine inverse of both sides. It's a lot easier as long as we have one angle. Now we need 2 sides. If we have 2 angles, no, law of sines.
SAS.
Law of sines. So in this homework, you might actually have some where it's like, go use law of sines, don't use law of cosines. They might have you choose. But question, which one? Which formula? If you're allowed to use all 6, now that you kind of get the idea, which formula do I have to choose out of the 6 for this example? I can tell you who we're missing. Because who's the one side you're missing? And who's the one angle that you have? Check it. Your law of cosines have bookends, right? Whatever side is here is whatever angle is here. So if you have angle B, I know I have to have B there. If I have angle C, I know I have to have side C there. That's what helps me as far as formulas. Now guys, the nice thing with the formulas is that they're all squares, at least with the first part. And whatever side is here, the other 2, whoever they are, get added, kind of like Pythagorean. Then I'm always subtracting 2 times whoever those 2 guys are, and then this guy's angle. That's how all the 1, 2, 3, the first 3 formulas work. Whoever's here, his angle, cosine of, is over there, and I have like a little Pythagorean theorem with a plus with the squares of the other 2 guys minus 2 times the other 2 guys, etc. So how am I going to solve for B? All you got to do is plug in. And Alec, you're going to have less error. You're going to have less, like my decimals are off, which could mess you up on a multiple choice. You're going to have less of that if you just type it in all at once. One big old square root of the whole shebang. One big old square root. 6.2 squared plus, now be careful that you're plugging in the right numbers. If something is a little weird or a little funny, just double check you typed it all in right. But if you do it all at once, you don't have to worry about like these multiple steps where you could have missed things. Once you get all this in, and once you get v is equal to.
Whoa.
Oh. There's too many letters.
Yeah. Ooh. Look at both lines. Oh, you're missing the armor.
Is that a fire alarm?
No, it's my phone.
Okay.
I was listening to the rustle of the bag, so if there
Oh,
was
no,
something
no.
else, I missed it. Sorry. Please ask what might bring you to me.
Sorry, we'll just break.
Guys, here's a struggle. We have 2 angles, so now what? Do we have A, B, and C? Could we put a different guy on this side now, besides B? Like, could we put him here? What would happen if we put A here? Who should go down here? Wait a minute, we have formulas that are arranged that way, don't we? Can't we go looking straight for A right now? Let's go looking for A. Whoever the angle is, we get to put his side first, so that's 6.2. Then we subtract the other 2 guys. Now, here's the problem. We're going to have to subtract this guy not rounded. We're going to steal the big old long version. Otherwise, your answer is not going to match up with mine. And then we have the other 2 guys, which is have the not rounded ones. But then all we have to do, guys, we can even do it right here. We can just say cosine inverse. And then like I was showing some of you on your calculators, you can do it all at once. And actually, I have it typed out with those other numbers. I'm just going to go back and change the numbers. I'm going to change the numbers to be my 6.2 squared minus 9.5 squared minus, I'm going to go get that nasty decimal and square him, because I don't want to introduce error. And I'm going to go plug in my 9.5. I'm down here now, just plugging it all in. And then I'm going to go get the big old long guy. I didn't want him there. Where is it? Sometimes it likes to be there. He's definitely not plugging in the right place. 9.943018113.
Infomercials like for insurance.
Is that helpful?
No.
Angle A is equal to 142.898. Whew. Now, it could be a real beast if we have to go solve for the other angle the long way. Guys, hold on. As soon as I have 2 angles, what can I do?
Minus 180. Keys.
180! 180 minus, wait! What's wrong? 75 and 142, I made a mistake. Who found it?
I don't know.
Keys.
Wait, someone just said my name. Did you find a mistake?
Oh, I did. I was asking. I don't know. I was asking.
Potluck club, I have to go.
We just put this stuff in the drawer.
Perfect.
In the bag.
Perfect. That's what I was hoping maybe. Did anybody solve and get something different? Did I plug it in? 6.2 squared minus 9.5 squared minus 9.943 squared all over 2 times 9.5. Am I in radian mode? No, I'm in radian mode.
Did you do B right?
I assume so. No one stopped me. Square root of 6.2 squared plus 9.5 squared minus 2 times 6.2. 7520. Did I do the formula wrong? Can anybody double check my formula? Is it cosine of A equals A squared minus B squared minus C squared?
A squared plus C squared minus 2 is the cosine of B.
Oh, cosine of A is B squared plus C squared? Oh, Steve. Yeah. Never mind. It's that, and then it's that, and then it's minus, and then it's that. Oh, yeah, that would totally must be. And then it's all over 2 2BC. Okay, that part was right. So it's that guy plus this guy. And then minus that guy. Note to self, should you guys maybe make sure you have the formula right? Yeah, good call. Oh. He's amazing. We're getting the right answer. Just taking this guy out. Take B squared away. You don't belong there. You belong at the end. B squared plus C squared minus C squared. Whew. Okay. 37. That makes way more sense. 37.102 degrees. And then, Alec, your idea was right. Just I had angles adding up to way more than 180, so I was in some serious trouble. I had to figure that out. But what were you saying about how I can find my third angle after all that work? Yeah, 180 minus him, and then I can go ahead and have my final answer. So the nice thing is, once you get 2 angles, it shouldn't be that bad to find the third. Because you just have to go ahead and use your and then 20 minutes. $67.56. Yeah.
Why do we have to use these formulas instead of the ones that we like? Why are we changing it?
We couldn't use law of sines. If we tried, we would have had sine of A all over 6.2 is equal to sine of 7520 all over. We have 2 unknowns.
Oh, okay.
See it? So when we have 2 sides, and one angle, and it's not SSA, law of sines actually is impossible until we solve for 1. Now, as soon as we solve for this, we could have actually not done law of cosines. We could have done law of sines instead, but it would have been an ambiguous case that we would have had to been like, wait a minute, is this the right one, or is the other one the right one? Whereas law of cosine says, no, this is the one, and you're done.
Okay.
Does that kind of make sense? But you could try, but if it doesn't work, then look. But in homework, there are places where it's like, use law of cosines or law of sines. You figure out which one's best. Because law of sines is sometimes easier. Yeah. Now, guys, in law of cosines, I know the bell is about to ring, but there is an SSS form of an area formula. And the SSS form of the area formula actually doesn't use cosines. It just doesn't use sines either. So they just give it to you as how to solve. And so actually, all you have to do is find this thing called a semi-perimeter where we just add everybody up. We divide by 2, and then we plug into the formula of, take this S guy and do him minus A, him minus B, and him minus C. And actually, the weird thing is that'll totally find you your area. So if you get this one number and then plug it in, type it in your calculator, one full string, without even needing to find any angles, you can just use that area formula and save a lot of time. You don't have the base, you don't have the height, but you do have enough information. Is that cool? Yeah. No, just plug it in.
Is it due Tuesday?
Here runs formula.
Is it due Tuesday?
Yeah, due Tuesday. Do phonies after Tuesday. Bring questions tomorrow. See you guys later.
No. Because you already dissed it. Yeah, you did.
Have a good weekend.
Thank you.
Why do I remember that? I did my homework once again. It was hi.
I'm just thinking about my Switch.
Did you play some Smash?
No, I had to do homework.
The math homework wasn't that bad.
No, but I had other homework.
Like what? Oh, like that one wasn't that bad either. Yeah.
I wrote the entire essay for what's it called? I can't function in that room. I can't focus. There's a bad vibe.
That's high IQ though. So here's the logic behind why you say this Tell me, please. Yeah.
Well, like, it's actually not that bad.
Yeah.
Yeah.
Same
Is it bad that I'm on? Is it bad that I look
Does he
like
squeeze the
Hamlet?
meat?
Okay, I need.
It naturally.
Dude, if I need Hamlet, this needs to be heated up. How does this
Oh
get
my gosh. Why complicated?
You
It
can't
doesn't
put
make
this
sense.
behind you.
Maybe, what's inside? You're right.
It's the
Yeah, that means
really
we're
fast.
everybody get rice for you, I'm sorry. Yeah, I have a container with the beans
But I
rice.
see you that. Yeah, but it's in a plastic.
Yeah. Oh. Yeah. You don't get all of it though.
No, it's
How? The only way guarantees you get all of it. Yeah.
It's
How much good?
But then it's right before your 3-day weekend, and then you get to, and you got, guess where?
Yeah, take them on. Yeah. Cut the station. I wish.
That's so fun with like, and just getting into it.
Sure, all of it. Let's get some of that. Okay, that's pretty high. I wonder how it actually garlic salt. I know. I use garlic salt for everything. I mean, eating but when I do, that's insane.